वाला खोल लूं। So just a second, let me open the right paper. It's क्या था W16 and and 4.3. ठीक है अच्छा remember कल we did a very important redox reaction, ठीक है, not very important था वो, खाली 2 मार्क का, लेकिन chain reactions का हमने उसमें किया था. अच्छा, we're going to continue with that question, ठीक है, that was the question that we were doing. So ठीक है, this is the right paper. We had done this as well. कहाँ पे है? अच्छा, this was the 2 mark question that we had spent like 20 minutes discussing, ठीक है. Question number 5 से start करते हैं. Question number 5 is, so it's a new question. So question 5 is, okay, this compound F contains elements carbon, hydrogen and oxygen only, ठीक है, तो बस it's CXHY OZ, ठीक है, we don't know how many carbons, how many hydrogens, how many oxygens. And what's given is that all carbon bonds in F are single bonds. तो इसका मतलब है it is saturated. So they're all single bonds. ठीक है, that's another thing. और फिर ये कि अच्छा उसके बाद क्या है कि what's given is कि the structure of F was analyzed by mass spectrometry and infrared and NMR spectroscopy. ठीक है, so there's the 3 analytical techniques that are being used. और तीनों में ये कि all 3 they provide different information. So starting with the first thing, the mass to charge value of the M peak is given, and that's 90. As a mass, just a quick revision of all the 3 analytical techniques. Okay, let me just open a whiteboard. Okay, very briefly, I'm just going to go over them very, very briefly. कि यहाँ पे कर लेते हैं कि मैं summary दे देता हूँ, ठीक है, कि what happens in mass spectroscopy. So let's talk about mass spectroscopy. Remember कि आपना what you do is कि you take a molecule, you ionize it, you turn it into a beam, and the beam is passed through a magnetic field, and the beam deflects. Charged particles, they get deflected in that magnetic field. So this is what's going on. The deflection is inversely proportional to mass. So basically what the deflection shows is the mass. If the particle is heavy, the deflection is going to be lesser. If the particle is light, the deflection is going to be more. So when you take a molecule, any molecule, for example, if I take CH3OH, so there is a molecular ion. There are different types of ions that are formed. One of them is a molecular ion, which is CH3OH plus 1. That's going to be the heaviest particle. And then there would be lots of fragments. In the ionization process, the molecule could break up into CH3 plus 1 tiny fragment, and H plus 1 fragment could be formed, and OH plus 1 fragment could be formed. So the heaviest peak belongs to the molecular ion, which is known as the M peak. And the lighter particles, the fragments, because they're light, they're going to be deflected more. So those are your fragments. And you're not going to get a single molecular ion peak because they can be isotopes. For example, if you have a CH3Cl molecule, And if it turns into an ion, which is CH3Cl plus 1, then the molecular ion is going to have different masses because Cl could be 35 and Cl could be 37. So the mass of the particle could be different. So you can have different versions of the molecular ion. And there could be M plus 1, M plus 2, M plus 4 peaks. The mass spectroscopy can, based on the probability of what isotopes exist in what quantity, there were certain rules that you would figure out. And the first thing is, molecular ion peaks, if you focus on the molecular ion peak, you figure out the mass of the particle. That's the first thing. And the second thing is, what are the other rules? The other rules are, if you have an M plus 2 peak, and it has a ratio of 3:1, that indicates that there is one Cl present in the molecule. Which in this question is not true because उसने question में clearly state किया था there was no Cl. I mean, there's only carbon, hydrogen, oxygen. I said,
Sir?
yes.
Sir, how does this 3:1 indicate 1 Cl?
I'm just going to talk about both of them. Just 1 second. 9:6:1 indicates that there are 2 Cls present. Okay. I said I'm going to explain why it represents 1 Cl. So think of CH3Cl. You turn it into an ion. Okay, let's move over here. You turn it into an ion, and that ion you ionize it, and there would be tiny fragments as well, like a CH2 plus 1 fragment and so on. But we're focusing on the biggest fragment, right? I mean the biggest ion. Now, Cl has two versions. There's Cl35, and there's an isotope of Cl, which is 37. And the relative abundance of both of them is that the probability of getting Cl35 is 3:4. So out of every 4 particles that you see, 3 of them is Cl35, and 1 out of 4 is Cl37. So you're going to get, the molecular ion is going to give you 2 deflections. Okay, they would be the least, they would have very less deflection because they are heavier particles. Okay, that's your molecular ion. There's going to be an M peak and there's going to be an M plus 2 peak. So why is there a difference between the masses of the molecular ion? It's this one that I'm talking about. Why are you getting two different masses? Because CH3 is 15, Cl could be 35 or it could be 37. If it's 35, then the mass is 50. And if the Cl is 37, the mass is 52. Okay, Mariam, is this clear up till this point?
Ji, sir.
So now, moving forward, what's the probability of getting Cl35? That's 3/4. What's the probability of getting Cl37? That's 1/4, right? So what's the probability of the particle having a mass of 50? That's 3/4. What's the probability of getting a particle with a mass of 52? That's 1/4. So when you actually detect these particles, the M peak, which is the 50 peak, which has a mass of 50, it would be detected 3 times more. The particle which has a mass of 50 would have a relative probability of 3/4, and the particle that has a mass of 52, this is the mass to charge ratio, would have a probability of 1/4.
Sir,
So
we know which one is M and which is M plus 2.
the lowest one is the M peak. Okay, when you have molecular ion peaks, the lowest one is the M peak, और उसके बाद में M plus 2 is because of the isotopes.
Okay, ठीक है.
ठीक है. So you have to remember this. अच्छा, फिर 2 Cl में क्या होता है? What if the molecule had 2 Cls? Now the molecular ion would be the same exact process. Okay, it's going to get deflected. So it's going to get deflected in the, but the molecular ion peak is going to have 3 deflections because there would be 3 different particles which would have the same formula, CH2Cl2. Okay, either both of the Cls are 35, so it's going to be 35 plus 35 plus that's 70 plus 14, that's 84. That's your M peak. ठीक है, molecular ion में जो lightest particle होगा ना, that's your M peak. और उसके बाद क्या होगा कि one of the Cls could be 37, so the mass would be different. It's going to be 86. It would be slightly heavier. तो उसकी reflection जो होगी वो थोड़ी कम होगी. And then there's going to be another one which would be 88 because both the Cls are 37, and that would be your M plus 4 peak. तो ये वाला जो particle है ना, there would be many different versions of this. ठीक है, 3 different versions. तो जब आप डिटेक्टर के ऊपर डिटेक्ट कर रहे होगे ना एंड प्लॉट कर रहे होगे, तो एक पार्टिकल होगा जो 84 वाला होगा, एक पार्टिकल होगा जो 86 वाला होगा, एंड देयर इज गोइंग टू बी वन पार्टिकल व्हिच इज गोइंग टू बी 88. यू विल बी डिटेक्टिंग 3 डिफरेंट पार्टिकल्स. और फिर इनकी प्रोबेबिलिटीज क्या थी कि व्हाट्स द प्रोबेबिलिटी ऑफ बोथ द सीएल्स कमिंग आउट टू बी 35? दैट्स व्हेन यू आर गोइंग टू, ठीक है. सो सीएल, द फर्स्ट वन इज सीएल 35 and the second one is CL 35. So it's going to be 3 by 4 into 3 by 4, and that would turn out to be 9 by 16.
16.
ठीक है. और इसी तरह ना the other ones कि if one of them is 37 and one of them is 35, so that would be 3 by 4.
6 over 16.
ठीक है. और वो 2 times क्योंकि 2 different scenarios होंगे कि या तो पहला वाला 35 है and the second one is 37, or the first one is 37 and the second one is 35. तो इस तरह वो probabilities आ जाएंगे. The last one दोनों 37 आने के chances सबसे कम होंगे. That would be 1 by 4.
1 over.
So that's 1 by 16. तो relative abundance जो होगी ना तीनों particles की, this would be 9 by 16. 84 आने के chances वो सबसे ज़्यादा है. This one would be 6 by 16 and this one would be 1 by 16. ठीक है, clear है ये?
Sir, so generally, as a rule, it's easier to get the lighter atom or the lighter molecule.
Nee, it depends on the probability. For you, you just have to remember about this thing, about chlorine. वो तो इसलिए lighter atom की क्योंकि particle उसकी probability ज़्यादा है ना.
Yeah, ठीक है.
क्योंकि it's 75% chances उसके Cl35 आने के. But for bromine, that's not true. Bromine के लिए things are different. क्योंकि bromine के लिए now this is for bromine. अगर वो equal probability होगी ना 1:1, that means one bromine is present. क्योंकि ब्रोमीन के 2 isotopes होते हैं, one is 79 and the other one is 81, और दोनों के equal chances होते हैं. ठीक है. तो अगर इसी मॉलिक्यूल में ब्रोमीन होता तो वो जो वेरिएशन आ रही थी दोनों की इक्वल चांसेस होते हैं, इक्वल अबंडेंस होती है. और उसके अंदर वही काम अगर ब्रोमीन के लिए करोगे ना, इट वुड बी M+2. अगर 2 ब्रोमीन्स होंगे तो इट्स गोइंग टू बी 1:2:1.
ठीक है सर.
अच्छा, तो this is one thing that you should know about mass spectroscopy. ठीक है, you should remember about mass spectroscopy. और एक और है, वो है कि you can figure out the number of carbon atoms. वो इस फॉर्मूले से फिगर आउट करते हैं, 100/1.1 into M+1 हाइट डिवाइड बाय M. ठीक है. उसके पीछे भी ना यही प्रोबेबिलिटी का चक्कर है कि उसके अंदर होता है कि there is कार्बन के अंदर 2 isotopes, one is 12 and the other one is 13. तो कार्बन में वेरिएशन से ना you get an M+1 peak. कि अगर किसी मॉलिक्यूल में ना कार्बन 13 आ रहा है ना, तो उसकी मास जो है that would increase by 1. So it's going to be M+1. But the relative probabilities are कि कार्बन 12 भी ज्यादा होता है, ये जो 13 है ना उसके चांसेस बहुत ही कम होते हैं. ठीक है, that's very you have very little chance of getting carbon 13. लेकिन what happens is कि अगर number of carbon atoms बढ़ते रहेंगे ना, तो ये जो ratio है ना, that keeps changing. And by focusing on the height of the M+1 peak, you can actually figure out the number of carbon atoms. तो ये फॉर्मूला याद रखना है. ठीक है, मैं उसकी डिटेल में नहीं गया. You don't have to. क्लोरीन का मैंने समझा दिए, तो उसी तरह इसकी प्रोबेबिलिटीज भी डील होती हैं. जस्ट हैव टू रिमेंबर दिस फॉर्मूला. ठीक है. So that's pretty much all about mass spectroscopy. One second. Achha, so that's pretty much all you have to know about mass spectroscopy. And the other thing about mass spectroscopy is कि जो fragments बने होते हैं ना, fragments that are getting detected, they provide you a lot of information about the structure of the molecule. कि अगर 15 का बन रहा है ना, you can pretty much guess कि there's a fragment of 15, which means that the molecule, the original molecule, has a small piece that has 15, and you can figure that out. अगर एक OH17 mass का particle detect हो रहा है, तो you can figure out कि there's an OH probably in there, ठीक है? So the fragments also provide a lot of information in figuring out the structure. Coming back to the question, सबसे पहला काम है is given you the m+1 peak. तो वो formula लगाओ, figure out the number of carbon atoms. Can somebody do that? Tell me the number of carbon atoms. Formula is 100 over 1.1 into m+1 height, which is 0.7, divided by the m height, which is 22.1.
Sir, it's 2.88, which I'm guessing you can round up to 3.
Okay, so you're going to round it off to 3. And he's saying, okay, that's 3, right? So plus m peak is given. That's the mass of the particle, the molecular ion. That's 90. So और क्या दिया हुआ है? Nothing much. mm+1 is given. That's the only thing that's given. Chlorine और bromine वाला काम तो है ही नहीं इसमें, क्योंकि उसने पहले he made it clear there's no chlorine, there's no bromine. Apart from that fact, suggest the molecular formula of F. Now you have to figure out कि 3 carbon atom वाली चीज जो है, now you just have 3 carbon atoms. How can that be 90? And is there, और उससे कहा है सारे single bonds है. That's given. और कोई information नहीं given. ठीक है, so you have to figure out the molecular formula. So all of them are single bonds. पहले तो 3 carbon atoms निकाल लो. If you take out 3 carbon atoms, that's मतलब 90 आना चाहिए, ठीक है? So we're going to figure out what's happening here.
But sir, in this case, aren't only the carbon-carbon bonds single bonds, so can't we still have like a C double bond O?
You can have that, ठीक है? उसमें सिर्फ carbon saturate का भी मतलब ये होता है the carbons are single bonded, ठीक है?
ठीक है.
5 plus there are 2 carbons, so that's 12 plus 12. So your total RS 69. So you're left with how much? You're left with 21. So again, if I add another
So add
oxygen,
an
okay, if I add another oxygen, so that's
so that'll exceed it. Let's just add an OH.
that's 85. Just 1 second. So you're left with 1H. 1H. नहीं ये पूरा नहीं OH होगा, ठीक है? क्योंकि this is coming out to be, this is 45. ठीक है, plus 12 plus 12 plus 16, so that's 85. I need 5 hydrogens, so let's put in a bit more hydrogens. So the double bond O नहीं होगा, it's probably going to be OH. ठीक है, so now this is equal to 90. And so how many carbons do you have? You have 3 carbons. You have how many hydrogens? That's 1, 2, 3, 4, 5, and 6. And how many oxygens you have? You have 3 oxygens. So now the thing is, this is not the structural formula. Okay, this is not the structural formula. It could have been the OH could be in the middle one. It would still be 90. Okay, it could be that the C double bond O is somewhere in the middle. It would still be 90. So there could be lots of molecules that have the same molecular formula, but the structure would be different. So remember, this is not the actual molecule. This is just we're trying to figure out how do you get 90 in a molecule. Okay, so we just figured that out. Now the next part is we need to guess. So we have one version of the molecule. I mean, which is probably not the right version, but we have an idea of what the molecule probably contains. Now we just need to figure out whether is the OH on this carbon atom or is it on this carbon atom. Is the C double bond O over here at the end or is it somewhere in the middle? Okay, so there could be lots of isomers that would have the same exact molecular formula. Okay, is this clear? Sakib clear? Mayim clear?
Sir?
Yes, sir.
Sir, so does that mean that mass spectrometry can only tell us about the molecular formula?
Exactly. I mean, mass spectroscopy only tells you about the mass. Okay, it doesn't tell you how those things are connected together. Well, you know the information that you're going to get from mass spectroscopy is like you're going to know that there are two CLs, but you don't know
Okay.
where they are. Okay,
Okay.
but the fragments can kind of help you in figuring out the structure. ठीक है? I mean, for example, there's a fragment that has a mass of 17. तो आप थोड़ा बहुत guesswork कर सकते हो and you can figure out कि maybe that's OH. ठीक है? Do you get my point?
Ji, sir.
So the fragments would be helpful in figuring out the structure. So anyways, coming back to this, now we're moving to infrared spectroscopy, and remember, we need to figure out which isomer of this thing is the actual molecule. Now infrared spectroscopy is given, and there's a broad and strong peak at 3350. So I'm going to open the data booklet now. ठीक है? अब infrared spectroscopy bonds जो हैं वो vibrate करते हैं. They absorb infrared frequencies when they do that. कहाँ पे इसका? Not this, not this. ये. अच्छा, now he's saying that there's a strong and broad absorption at 3350. It's probably an OH. ठीक है? 3000 से ऊपर ना, that's I mean, there is no N, so we can rule that out. 3000, 3100 weak absorption, so it wasn't a weak absorption, it was a strong and very broad, so it's probably an OH. So that is something that we can figure out. So type of bond, that is an OH. The functional group, because it's broad and strong. और पहले बाकी भी देख लेते हैं. There's a very strong absorption at 1725 as well. Now 1725 is a very unique absorption. 1725 is the absorption because of this thing. ठीक है? Serial bond O, that's a pretty unique absorption. That's a serial bond O. और exactly किस पे था? It was 1725 to be very exact, because these are ranges. ठीक है? वो सारी ranges overlap कर रही हैं. So you can't really figure out which one it is, but you know that it is a serial bond O. So that's a serial bond O. So what about 2680? You're getting a strong and broad absorption at 26, a very broad and strong absorption at 2680. So if we go and have a look, if you go and have a look, कहाँ पे? So 26 strong and very broad. So it's probably this one. So the thing is, our molecule actually has two OH groups. I think we pretty much came very close in drawing the correct structure. There's an OH group in the carboxylic acid, and there's an OH group that is not part of the carboxylic acid. So if it's a very broad and strong absorption, that's still an OH group, but that's an OH group that belongs to the carboxylic acid functional group. क्योंकि डेटा बुकलेट वही कह रही है. डेटा बुकलेट सजेस्ट के OH की ना, if you get a very strong and very broad absorption, 2650 within that range, so that's the OH that belongs to the carboxylic acid. और वो 3200 से आगे भी हमें absorption मिल रही थी, that was probably an OH that belonged to a simple alcohol. ठीक है? So this one is the simple alcohol functional group. और फिर molecule के अंदर carboxylic acid है, तो it's probably going to be this one. This serial bond O belongs to the carboxylic acid group. So we pretty much came very close to actually drawing the correct structure in the first go. ठीक है? Is this clear? Abu, clear? Anam?
Ji, sir.
अच्छा, so ये बस याद रखना कि when you talk about infrared spectroscopy, this is very easy to identify. OH that belongs to carboxylic acid, that's also kind of easy to identify क्योंकि 2500 3000 पे there's going to be a very broad absorption. और अगर 3200 से ऊपर चले जाओगे तो usually it's just an alcohol. ठीक है. Carboxylic acid वाला जो OH है ना, that's usually before 3000. Apart from that, most other bonds, their infrared spectrum, they kind of overlap, so it's harder to actually figure out which one is the correct one. अच्छा, तो हमारा जो molecule हमने पहली attempt में बनाया था, that was actually pretty accurate. Okay, there was an OH that belonged to an alcohol, that's there. There was an OH that belonged to carboxylic acid, that's also there. And there's a serial bond O that belonged to carboxylic acid, that's also there. The only thing that's left is that we need to figure out कि OH कहाँ पे है. Is it on the carbon at the end, or is it on the carbon at on the middle one? ठीक है, that's the only thing that's probably left now. So now you're moving towards Nmr spectrum, deuterated trichloromethane.
Sir, I wanted to ask, do we have to study AS level chemistry, organic chemistry as well to understand it? Like, do they include, sir?
हाँ, infrared spectroscopy तो वैसे ही AS की है. ठीक है. अच्छा, ये वाला माइक प्लीज ऑफ कर लेना. अच्छा, ये वाला ड्यूट्रेटेड CdCl3. अच्छा, पहले थोड़ा सा इसका आइडिया दे देते हैं कि ड्यूट्रियम जो है ना, that doesn't resonate. और थोड़ा सा just a very quick brief overview of what NMR spectrum is. ठीक है. NMR spectrum होता है कि if you have odd number of nucleons in the nucleus, जैसा हाइड्रोजन के पास ना, there's only one proton. So what happens is that the magnetic fields are not paired. Every elementary particle has a magnetic field, protons, neutrons. So अगर वो even होंगे ना, तो they're going to cancel each other out. But if there are odd number of nucleons in the nucleus, so most of the elements, they have even number of nucleons. Carbon, oxygen, nitrogen, they have even nucleons. Nitrogen is 14, oxygen is 16. Okay? So a lot of them have even number of nucleons. Apart from hydrogen. So hydrogen की ना एक magnetic field होगी, ठीक है? And that magnetic field could be pointing in any direction. Then what you do is you put the molecule which has these hydrogen atoms in a very powerful external magnetic field, and that external magnetic field is pointing in this direction. So what happens is कि ये सारे के सारे protons, ठीक है, they're going to start to point. Sorry, one second. I said they're going to start to point in the direction of the external magnetic field, which is known as the aligned spin. तो इसका जो magnetic field जैसा magnet होता है, ठीक है, या compass की needle होती है, which aligns with the external magnetic field. So that's what happens. और जब वो होता है, फिर आप you give it radio frequency. That's a low energy state. That's known as an aligned spin. That's the low energy state. You give them radio frequencies, which is why it's very safe. Radio waves are not very harmful. तो अगर human body की भी MRI scan होगा तो it's not going to be harmful. The proton becomes energetic and it starts to go into the opposing spin. So the opposing spin is the high energy state. So you have a low energy state and you have a high energy state, and there's this energy gap between them. And this energy gap is proportional to a very specific frequency. So from the radio spectrum, the proton is not going to absorb any random frequency. You can't चला गया. अच्छा, it's 1 second. अच्छा, so it's not going to absorb any random frequency. It's going to absorb a very specific frequency. Let's call that F naught. ठीक है? And that's resonance. तो आपका radio spectrum में ना, there would be a very specific frequency that's going to disappear, and this frequency depends on the chemical environment. It depends how the molecule is shielded. So for example, you have a molecule. और उस molecule में ना, the hydrogens are the ones with the magnetic field. So they have these tiny magnetic fields and they are aligned. Now, these three hydrogens have exactly the same chemical environment. They're exactly bonded the same way, and they would all resonate at exactly the same frequency. Unka jo energy gap hoga na between a line and opposing spin, that would be exactly the same. Let's call that frequency F1, and this would resonate at a different frequency. Because uska jo nucleus hai na, that's shielded differently. It experiences a different amount of external magnetic field. So it's going to resonate at a different frequency. So aapka jo spectrum hoga, uske andar, you're going to see two very distinct frequencies getting absorbed. F1 would be absorbed more, F2 would be absorbed less. So wo jo height hogi na absorption ki, that represents the number of hydrogens. तो आपको पता होगा कि there are three hydrogens in the same environment and there's one hydrogen which is kind of in a different environment. तो अगर bonding जरा सी भी different होगी, अच्छा अगर आपकी environment हल्की सी भी different होगी, the resonant frequency is going to change. And apart from that और ये table दिया हुआ है chemical shift का, ठीक है, you don't actually use the term frequency. What you do use is chemical shift. So every molecule is going to have different hydrogen protons and they would be resonating at different frequencies. Some of them are going to have the same environment, so they're going to absorb the same frequency. Some are going to have a different environment and they're going to absorb a different frequency. Ek to ye. That's the number of chemical environments. Okay, that's the first thing you know from the Nmr spectrum. The other thing is, what you get to know from the Nmr spectrum is the splitting pattern. अच्छा splitting pattern है कि there's an n+1 rule. Okay, all these absorptions are not going to be unique single peaks. The rule is if the neighboring carbon has n hydrogen atoms, so the peak would have n+1 subpeaks, or it would be split up into n+1 peak. So if the neighboring carbon has one hydrogen, it's going to be a doublet peak. If the neighboring carbon atom has no hydrogen, it's going to be a singlet. If the neighboring carbon has 4 hydrogen, it's going to be, so I'm just going to explain this quickly using an actual molecule. Okay, let's say I have this molecule. So how many different frequencies would be absorbed? How many different chemical environments would you have? That's one. That's the second one. And that's the third one. Okay, so I've grouped the hydrogens. These would resonate at frequency F1, this would resonate at frequency F2, and this would resonate at frequency F3. Okay, the two CH3s. I should just wait 1 minute for the azan. अच्छा चलिए वापस आवाज आ रही है सारा, can you hear me?
Yes, sir.
अच्छा, so you I was talking about the splitting pattern, ठीक है? So it's these three hydrogens environments I have grouped together. They're going to resonate at one frequency. This is going to resonate at a different frequency. Remember, this CH3 and this CH3 are different from each other. कि उसका जो neighborhood जो है ना, that's different. It's bonded differently. And these hydrogens are going to resonate at a different frequency. So they're basically three frequencies that are going to get absorbed. F1, F2, and F3.
Sir, why exactly are the different CH3s different?
Because they're bonded differently. I mean, this one is bonded to a CH2, this one is bonded to a C double bond O. तो
Oh,
वो
okay.
करेगा क्या? वो होगा ये कि if it's bonded to a, like it's close to an electronegative element, right? तो shielding थोड़ी सी different होगी. The oxygen is going to try to pull the electrons away from the hydrogens, right? तो वो जो
Yeah.
hydrogen का जो proton होगा ना, ये let's imagine this is the hydrogen proton, ठीक है? So it's उसके इर्द गिर्द ना electrons को इतने ज़्यादा होंगे नहीं. बल्कि let's assume कि fully exposed हो गया वो, ठीक है? The electron shielding, the electron cover around it is removed. कि वो oxygen है ना, electrons अपनी तरफ pull कर लिए. So this hydrogen proton is going to experience a lot more external magnetic field now. It would be a lot harder for it to resonate. Is this clear?
जी sir.
On the other hand, अगर उसके इर्द गिर्द ना electrons होते हैं, the hydrogen proton was, I mean, there was an electron cloud around it. ठीक है? No one was pulling it away from it. So the hydrogen proton would not be experiencing a lot of magnetic field, the external magnetic field. So it would be a lot easier for it to resonate and go into the opposing spin. तो उसकी frequency change हो जाती जिसके ऊपर वो resonate कर रहा होता. अच्छा, so बस ये splitting discuss कर लेते हैं कि F1 की height जो होगी वो 3, 2 and 1, right? जो singlet, doublet और triplet का concept था, that was कि इसके जो hydrogens resonate कर रहे होंगे ना, the neighboring hydrogens would be interfering with it. So if the neighboring hydrogens are 2, the peak for this one would split into 3. So it's going to be a triplet peak. These hydrogens would be resonating, and the neighboring hydrogens would be interfering with it. So if these hydrogens resonate and it has 3 neighborhood hydrogens, so this one would be a quadruplet peak. 4 में split होगी, n+1 rule. कि neighbor के पास अगर n है, तो उसकी peak n+1 में split होगी. Look at these CH3s now. Their neighborhood has no hydrogen. तो इसका मतलब it's not going to split at all. It's going to be a singlet peak. So there's a singlet, quadruplet and a triplet peak. और इसमें ये याद रखना है कि if there's an oxygen or there's an N, the lone pairs on N and the lone pairs on O, I mean let's think of CH3OH or a CH3NH2. Because of the lone pairs, the interference between the two sides would not happen, and there would be no splitting caused. The OH peak is always going to be a singlet, and the NH2 peak is always going to be a singlet. It's not going to split its neighbor's peak. Okay, the OH is not going to split the CH3 peak, and the CH3 is not going to have any effect on the H over here. So mutually now they would be separate. Okay, you would have to think they're not affecting each other. So बस ये इसमें number of chemical environments, the height shows the number of hydrogens in that particular chemical environment, and then you have the splitting pattern, which tells you how many neighborhood hydrogens do you have, and the rest is in the data booklet. You can actually figure out the frequencies, and you can match which environments are going to resonate at this particular frequency. So anyways, coming back to the question, जल्दी से देखो इसमें कि how many different environments do you have? That's 1, 2, 3 and 4. So there are 4 different environments. Now, when it comes to Nmr spectrum, always remember the way you're going to answer this is we already drew one molecule, which was this one. The only thing that was left was we had to figure out कि OH यहाँ पे है या is the OH somewhere in the middle. So I'm going to draw both molecules. ठीक है, let's say this is one molecule. There's double bond O and OH. The OH is on the middle carbon atom. So that's one version. And the other version of the molecule is जो ऊपर draw हुआ था, that was the carboxylic acid. और फिर यहाँ पे ना there's OH यहाँ पे था. And there was the two H's. ठीक है, that's it. और इसमें याद रखो कि अगर किसी ने डिटेल में पढ़ना है ना NMR स्पेक्ट्रम, सो वो मुझे कर दो, we can schedule that. ठीक है. अच्छा, that's the only two isomers possible. क्योंकि infrared spectroscopy से we already figured out कि there's a carboxylic acid and there's an OH. तो carboxylic acid तो NP होता है, तो OH की position आप आगे पीछे कर सकते हो. So it's either in the middle one or the one at the end. Now I'm going to look at the chemical environments. Which one has 4 different chemical environments? ठीक है साकिर. अच्छा, so which one has 4 different chemical environments? This one. ये एक अलग frequency पे resonate करेगा. This OH is different. The CH3 is different and this H is different from the rest. So there would be 4 different absorptions. There are 4 different chemical environments. Achha, what about this one? This OH would resonate at a different frequency. The two CH2s, ये जो दो hydrogens are there, they're going to resonate at a different frequency. These two hydrogens are exactly the same, so they're going to resonate at a single frequency. And this OH is different from the others. So जहाँ तक 4 different environments की बात है, they both have 4 different environments. ठीक है, so we can schedule that as well. अच्छा, so there are 4 different environments. चलो कल यही करेंगे फिर. ठीक है, ये डिटेल में ना NMR स्पेक्ट्रम डिटेल में पढ़ेंगे और इसी के क्वेश्चंस करेंगे. ये मैं बस जल्दी से लेट मी ट्राई एंड रैप दिस क्वेश्चन अप कि 4 डिफरेंट एनवायरनमेंट स्प्लिटिंग पैटर्न. देखो अब कि स्प्लिटिंग पैटर्न क्या होगा. लेट्स रिमेंबर OH की पीक्स स्प्लिट नहीं करती. ठीक है, सो OH की पीक्स अभी मैंने एंड में कहा था, दे डोंट स्प्लिट, सो दे आर सिंगलेट्स. तो यहाँ पे ना in the NMR spectrum drawn there are 2 singlets. This one is also a singlet. ठीक है, कल याद रखना, कल NMR spectrum ही करेंगे. ठीक है, स्क्रैच से और डिटेल में. अच्छा, तो अभी तक दोनों चीजें मैच कर रही हैं. अच्छा, what about the splitting pattern? कि इसकी स्प्लिटिंग देख लेते हैं. इसके नेबरहुड में कितने हाइड्रोजन्स हैं इसके नेबरहुड में. रिमेंबर OH doesn't count क्योंकि वो शील्डेड होता है. तो there's this carbon in the neighborhood with 3 hydrogens, तो इसकी जो peak होगी ना, that's going to be a quadruplet peak. और so which is, you do have a quadruplet peak. So I think this looks like the correct molecule. इसमें देख लेते हैं, do we get a quadruplet peak or not? These hydrogens are going to resonate and the neighborhood has 2 hydrogens. So it's going to be a triplet peak. So इससे you can figure out कि there is no triplet. There's either a doublet, a quadruplet, a singlet or a singlet. तो इसका मतलब you don't have a triplet. मतलब this CH2 is coming out to be a triplet. This CH2 is also coming out to be a triplet क्योंकि इसके जो neighboring carbon पे there are 2 hydrogens, so this is going to be a triplet as well. तो इसका मतलब है the NMR spectrum doesn't actually match with this. ठीक है, it's actually matching with this. ठीक है, इसके साथ मैच कर रहा है. और तो यही से आपने ना, you don't even have to open the data booklet. You've been able to figure out what is the right molecule. The OH must have been on the second carbon atom. Or by just figuring out how many different chemical environments are there, and how many different splittings are happening. By just looking at that, you are able to figure out that this is the molecule. और फिर आपने डेटा बुकलेट से ना मैच करना है. उसने कहा है कि ये चारों पीक्स को आइडेंटिफाई करो. तो we've already identified कि जो 4 के ऊपर जो थी ना, that was the quadruplet because of this thing, ये वाला. ये जो डबलेट आ रही है वो इसकी आ रही है क्योंकि इसके नेबरहुड में there is one hydrogen. तो that's a doublet. और फिर 2 singlets आ रही है, एक OH की वजह से, एक और OH की वजह से. In the data booklet, if you look at the data booklet, or H-NMR को focus करो. If you look at the data booklet, the OH that belongs to carboxylic acid, that gives a peak at 9 to 13 chemical shift. And 9 to 13 is this one. So this one, this singlet peak is this one, 9 to 13 wali. And this other one, फिर एक ही रह जाती है, but that's the one at 4.5. चलो ठीक है. खैर anyways, अब पता नहीं ये कितना समझ आया होगा. We're going to do Nmr Spectrum tomorrow in detail. ठीक है. ये तो हम क्वेश्चन कर रहे थे. I was assuming you had some strong concepts about Nmr Spectrum, but we're going to do Nmr Spectrum in detail. और फिर कल उसी के ऊपर करते हैं. वो टेस्ट वगैरह हम ले लेंगे बाद में. फिर Nmr Spectrum जो है ना उसके ऊपर फोकस करते हैं सारा डिटेल के अंदर, आराम से एक एक चीज समझ के फिर हम वो करेंगे. लेकिन वो कल करेंगे. ठीक है. 6 PM. ठीक है.
ठीक है सर.
Sir, the message they said about the NMR, is it like a test or because my internet cut off? So
No, it's
I
just
didn't listen.
not a test. We're going to have a class, probably a longer
Yes.
class. Just
Okay,
focusing.
I'll also join. Yes.
चलो ठीक है. Okay then.
Okay, sir. Allah Hafiz. See you.
Thank you, sir. Allah Hafiz.
Thank you, sir.